Alright, so let's go ahead and get started today. Kirk's going to have a handout for you, and I'm going to try to zoom in a little bit. So go ahead and get some paper out, get your approved calculator, and let's go through the review problems. Alright, so let's look at this first problem. Trying to get it to zoom to get it a little better quality. There we go. Alright, so notice we have absolute value as well as an inequality. So we're trying to isolate the absolute value because that's our first step. So I need to subtract 3 for both sides. So absolute value of 2x minus 1 is going to be less than or equal to 5. Alright, so I'm noticing that the inequality is pointing toward the absolute value, indicating that it's going to be an and problem, meaning it's going to be written all together. Remember, Kirk uses the word "andwich," meaning it's sandwiched all together, and I reference the ice cream sandwiches. So on the left-hand side, we're going to write a -5, keep the same inequality, drop the absolute value, rewrite 2x minus 1, keep the same inequality, and then rewrite 5. Once again, it's written all together like a sandwich. Alright, so we're going to add 1 to all 3 parts. What do I mean about all 3 parts? To the far left of the inequality, the middle part between the 2 inequalities, and after the last inequality. So all 3 parts. So we have a -4 less than or equal to 2x less than or equal to 6. From here, we're going to divide by 2. Once again, all 3 parts. So I have a -2 less than or equal to x less than or equal to 3. Remember, you read that from the inside out. I kept mentioning to you like Oreo cookies. You know, some people like to twist the cookies and start eating the inside part first. Well, that's how we're going to approach this. We're looking for numbers less than or equal to 3 and, because remember this is an and problem, and greater than or equal to a -2. You read it from the inside out. It's not necessary to write the word and, because when it's written all together, once again, like Kirk referring to it as a sandwich, an andwich, it's understood that it's and. So it's never an or problem when it's written in this form. If you're making that association that is incorrect, once again, it has to be an and based on the way that it's written. Alright, so let's go ahead and graph. We're including the 3. So notice my dots colored in. -2, we're going to include it. How do we know we're including it? We'll look at the or equal parts. Then we're looking at the information between in terms of our solution set. So how would we write that in interval notation? So we would write bracket -2, comma, 3, bracket. We're using bracket because we're including those values. How do we know we're including? Look at the inequalities, or equal parts. Alright, so that's problem 1. We've solved it, we graphed it, and we wrote it in interval notation. We're going to move on to problem 2. Problem 2. Alright, problem 2. It's a little different. Notice we do not have any absolute value. So it's neither an and nor an or problem. That's a hard word to say in combination. So it's not an and problem as well as it's not an or problem because we do not have absolute value. So we solve it the way that it's listed. So I need to get rid of the parentheses. How do I get rid of the parentheses? Well, we're going to distribute the 2. So that's 2x minus 6 plus 6 greater than a -3x minus 20. Now you may be wondering, how come I didn't distribute the 2 to the +6 over here? Well, it's not contained within the parentheses. So I shouldn't be distributing it beyond the parentheses. At this step, we're going to combine like terms, looking at the information on the left. Notice we have the negative 6 and the positive 6. Those are going to cancel, leaving me with 2x greater than a negative 3x minus 20. I want my x terms on the same side, so I'm going to add 3x. I have 5x greater than a negative 20. Still trying to solve for x, so I need to divide by 5. Since I'm dividing by a positive 5, it's not going to change the direction of the inequality. So notice it's staying the same. So we're looking for numbers greater than a negative 4. Alright, so let's find a negative 4. We're not including that value in part of our solution set because I don't have the or equal. From here, I'm looking for numbers greater than that. So from that open circle, we're going to go to the right. We're going to write that in interval notation. So it's going to be parentheses, a negative 4, because we're not including the negative 4, comma, infinity. And with infinity, you always use parentheses. So that's what the solution set would look like in interval notation. Once again, hopefully you can tell that's an open circle. We're not including it. And we're going to the right from that open circle. Just to reiterate, we're not writing it as an and or an or problem because we do not have absolute value. So I only need to work the problem that's listed. So we're looking for numbers greater than a negative 4. Alright, so that's problem 2. Let's go ahead and move on to problem 3. Problem 3, they're asking us to determine the slope. That's significant, so I'm going to circle that. Determine the slope of the line that contains the 2 points, a negative 30, negative 7, as well as a negative 2, 3. And it says I got to do it algebraically, meaning I have to use the formula. So let's rewrite the formula based on our prior knowledge, our prior discussions. So m, which is another way of saying slope, equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So it says I need 2 points. So we're going to find the slope given the 2 points. So let's label our points. I'm assuming you're going to call this one point 1 because it appears first. So that would be x sub 1, y sub 1. Alright, let's move to this other point. I'm assuming you're going to call it point 2, which is x sub 2, y sub 2. Alright, we're going to plug in. So m equals y sub 2, which is 3. The formula says I have to subtract. What am I going to subtract? Well, where's my y value? My y sub 1 value. It's a negative 7 divided by x sub 2, which is a negative 2, minus, because the formula says we have to subtract, we're going to subtract a negative 30. So m equals, remember when you subtract a negative, it's the same thing as adding a positive, so that's really 3 plus 7. The bottom part's a negative 2 plus 30. Let's keep going. Numerator, that's a positive 10. Denominator, that's a positive 28, but it has to be reduced because they're both divisible by 2, so that's 5 over 14. Just want to make sure that I finish the problem before I box it in. They only asked me to find the slope. So this is the only thing they asked for, so I'm finished with the problem. Find the slope of the line. Keep in mind, it's beneficial sometimes to label the information so you don't accidentally place it in the wrong location. This makes it a little bit easier for you. Also, rewriting the formula is beneficial to help you memorize it because you're going to have to know it for the test. That formula will not be provided. Alright, so that's problem 3. Let's move to problem 4. So let's see. They say find the equation of the line where the slope's 2/3. Notice my 2 got cut off a little bit, but it should be on your handout. And contains the point 5, negative 8. Write the equation of the line in standard form. Alright, so let's talk about the equation of the line. They're saying I have to end up with an equation and it has to be linear at the end. And then they're saying the final form has to be standard. So I have my slope and I have a point. So I need to use point slope. That's where I need to start, which is y minus y sub 1 equaling to m times x minus x sub 1. Just rewriting the formula. Once again, to help you, need to have it memorized, so the more you write it, say it, use it, it comes easier. So this is my point 1, meaning subscript of 1, so that's x sub 1, y sub 1. And here's my slope. Alright, so y minus a negative 8. Once again, the formula says I have subtraction. Y sub 1 is a negative 8. Equaling to my slope, which is 2/3, times parentheses x minus 5. If I can simplify my signs, I need to do so. It'll make it easier to work with. So subtracting a negative is the same thing as adding a positive. So y plus 8 equals 2/3 parentheses x minus 5. Alright, we got to distribute. I need to get rid of the parentheses. So y plus 8 equals 2/3 x. A positive times a negative gives me a negative. That 5 is really 5 over 1. So that 5 is really 5 over 1. So we're just going to multiply straight across. So that's 10 over 3. See, that wasn't too painful. Alright, from here I'm trying to solve for y, so I'm going to subtract 8. And remember, when you're dealing with fractions and you're adding or subtracting, you have to have an LCD. So off to the side here, I'm going to find my LCD. So the LCD would be 3, because that negative 8 is really a negative 8 over 1. So we have a negative 10 over 3. That's not changing. That negative 8 is really a negative 8 over 1. So I would need to multiply top and bottom by 3. So I need to multiply top and bottom by 3 to end up with an equivalent fraction. So that's a negative 24 over 3. Now some of you are like, I'm not really sure if I did it correctly. Well, there's a way of verifying it. What's a negative 24 divided by 3? It's a negative 8. So we did it correctly. So y equals 2/3 x minus, combine those two fractions, 34 over 3. Alright, and then we're thinking, woohoo, we're finished, but we're not. It was like psych. Alright, so I need my x and y term on the left-hand side. So, once again, I'm referencing standard form if I lost you. I have to go a step further. Alright, so let's move this 2/3 x to the left. I need to subtract 2/3 x. Because remember, with standard form, the x and y terms have to be on the left, no fractions, and a has to be positive. So we're still not finished. So I need to multiply through to get rid of the fractions, and I also want this to be positive. So let's multiply through by, I'm trying to find another colored pen. Let me use a pencil. So let's multiply through by a negative 3. Alright, so why are we using a negative rather than a positive? Once again, I want that x to be positive. So a negative times a negative is going to give me a positive value. So that's 2x minus 3y equaling to a positive 34. And this would be standard form. Now, if they didn't ask for it to be in standard form, we would have stopped here and that would have been my final answer. But once again, they asked for it to be in standard form, so I had to go a step further. Alright, that's problem 4. We're going to be moving on to problem 5. Let me give you a quick glance at this one before I move on. with absolute value again. So we need to isolate the absolute value. What exactly does that mean? The only thing I want on the left-hand side is the absolute value of 7 minus 4x. That's it. So I got to subtract 5 from both sides. So we have the absolute value of 7 minus 4x equaling to 3. Remember we talked about in class, for this to be a true statement, what would have to be on the inside? Meaning, what would have to be underneath my finger? It would have to be either a negative 3 or a positive 3. So whatever's underneath my finger, which was the 7 minus 4x, needs to be a negative 3 or a positive 3. So 7 minus 4x equals a negative 3, or 7 minus 4x is going to equal to a positive 3. So notice at this stage we should not have absolute value, which we do not. We have two equations, we need to solve them, so let's subtract 7. A negative 4x is going to be a negative 10. We're going to divide by negative 4. So x is going to end up being a positive value because a negative divided by negative is positive. They both can be reduced by 2, so it's going to be 5 halves. Over here, we're going to subtract 7. A negative 4x is going to equal to a negative 4. We're going to divide by negative 4. So a negative divided by negative is going to give me a positive value. 4 divided by 4 is 1. So we have two answers. One being 5 halves, the other one being a positive 1. You could verify that, meaning you could verify that the two answers are correct by plugging into the original problem, which is a really good idea because it gives you an indication if you're on track, if you have a good understanding of it. So we're finished with problem 5. Let me give you a second to look at it, and then we're going to move on to problem 6. All right, problem 6. Give me 1 second with problem 6. I noticed that there's a mistake on this sheet of paper. Alright, so they're asking us to graph. They want us to graph a negative x minus 3y less than a negative 3. They're asking us to graph. Alright, remember this one's going to be a 3-step process. Step 1. We get to pretend that we have equals. So in place of that inequality, we get to put an equal sign. Alright, so from here we're going to solve for y. I need to move this term to the other side, so I'm going to add x. A negative 3y is going to equal to x minus 3. Still need to go a step further, so we're going to divide by negative 3. Y is going to be a negative 1/3 x plus 1. Now you may be wondering where that 1 came from. It may be helpful to put the 1 in front of that x because it's understood to be there. So we have a negative 1/3 x. This plus 1 came from a negative 3 divided by a negative 3. Alright, so my slope's a negative 1/3. The y-intercept is 1. Some of you need to see that as a point, so that's 0, 1. Alright, so let's go ahead and graph. Y-intercept, 0, 1. Find that lovely little point. Let's use the slope. Remember, the slope is referencing rise over run. So we're going to go down 1 to the right 3. Down 1 to the right 3. Alright, step 2. I got to determine if it's a solid or dotted line. In this case, it's a dotted line. How do I know it's a dotted line? Well, look at the inequality. It's less than. It doesn't have the or equal. So it's going to be a dotted line. Some textbooks refer to it as dashes. Alright, step 3. I need a test point. test point is any point not on the line. So we usually like to use 0, 0 because it's one of the easier points to plug in. And keep in mind, I can always use it as long as the line does not go through it. The line does not go through 0, 0, so I'm going to use that point. Please identify the point that you're using because it may be different than the one I'm suggesting. So let's plug in, rewrite the original problem because it needs to go into the original problem, and plug in 0, 0. Alright, so we're trying to determine whether that's a true statement or not. So is 0 less than a negative 3? Well, you may want to think of it as money. Would you rather have a 0 balance in your checking account, or would you rather owe $3? Well, once again, 0 is not less than a negative 3. So this is a false statement. It's a false statement. So let's think of this like a treasure map. 0, 0, that's my test point. So I'm going back up here, finding it. We've determined this side is false. Why are we saying it's false? Well, we tested it. We tested the point, and that point's located on this side, and it's false, meaning this side has to be true, and we only shade the side that's true. Once again, my test point's located here. It's a false statement. How do I know it's a false statement? Well, we plugged it in. We tested it. So this is a false side, meaning this side has to be true, and you only shade the side that's true. All right, review that one a little bit, and then we're going to move on to 7. Alright, problem 7. Oh, we have all these lovely little fractions, so much fun. Just a short period of time. Alright, so it's an inequality, but notice there's not any absolute value. There's not any absolute value. So we're only going to solve it the way that it's listed, meaning it's not an and problem, and it's not an or problem. It's neither one. Just solve it the way that it's listed. Alright, so we want to get rid of the grouping symbols, meaning the parentheses. So let's distribute the 1/2. So that's going to be 5 over 2x minus 1/2 minus 1/3 greater than, distribute the 3, 3x minus 3/2. Be careful. You may be wondering, how did you get 5/2? Well, that 5x is really 5x over 1, or 5 over 1, another way of looking at it. This 3 is really 3 over 1, so we're just multiplying straight across. From here, I want to multiply to get rid of the fraction. So I'm looking at the LCD, trying to determine what that would be, and then we're going to use that information and multiply through by that value. So noticing that the LCD is 6, we're going to multiply both sides by 6. Alright, so let's distribute that 6. Remember, whatever you do to one side, you have to do to the other side. It doesn't matter if this side didn't have a fraction. I still have to multiply through by 6. So 6 times 5/2 x is going to give me 15x. 6 times a negative 1/2 is a negative 3. 6 times a negative 1/3 is a negative 2. Greater than 6 times 3x is 18x. 6 times a negative 3/2 is minus 9. Alright, so let's look on each side of the inequality and see if we can combine like terms. So I'm looking at this side. Do we have any like terms? Sure we do. A negative 3 combined with a negative 2 is a negative 5. Rewriting the other information, bringing me to this step. I want my x's on the left, and the reason I'm wanting them on the left is it makes it easier since we're going to have to graph. So I'm going to subtract 18x. Now you could have picked a different option. You could have subtracted 15x from both sides, but at the end when you're graphing on the line, it's going to make it much easier if the x is on the left. So we have a negative 3x minus 5 greater than a negative 9. Don't forget about the sign, so I'm bringing it down. We're going to add 5. I have a negative 3x greater than a negative 4. Alright, now notice I'm going to have to divide by a negative 3. And because of that, it's going to change the direction of the inequality. So anytime you multiply or divide by a negative value, it changes the direction of the inequality. Alright, so let's keep going. X is going to be less than 4/3. Alright, I need to graph it on the number line. Alright, so let's think of that 4/3 as a mixed number. If I was dividing that out using long division, which I can illustrate off to the side here, 3 is going to go into 4 one time. Remainder of 1, so that's 1 1/3. So 1 1/3. I need to find that on the number line. Here's 1. Think of this as 3 equal parts. I'm going to take one of them. So that's 4/3. Are we including the 4/3? No. How do I know we're not including it? Because it's not underlined. It doesn't have the or equal part. We're looking for numbers smaller than that, so we're going to go to the left. I need to write it in interval notation, so that's going to be parentheses, a negative infinity, because that keeps getting smaller, comma, 4/3. We're not including the 4/3, so I need a parenthesis. So that's how you would write it in interval notation. You never use a mixed number with interval notation. It's just not proper notation. So once again, you never, ever, ever, ever use a mixed number in reference to interval notation. Alright, let me give you a second to look at that, and we're going to move on to 8. Alright, problem 8. Notice we're dealing with two absolute values. So we've talked about in class, that's going to be referencing same as well as opposites. So same and opposites. Remember with same, you just drop the absolute values. Drop the absolute values. Opposites, you're going to drop the absolute value on the left. On the right hand side, you're going to drop the absolute value and change the sign of all the terms. So that's a negative 4x plus 3. Once again, you're changing the sign of both terms. Alright, so let's go back to this idea of same. I want my x's on the same side, so I'm going to subtract 2x. I have a negative 1 equaling to 2x minus 3. We're going to add 3x. 2 is going to equal to 2x. We're going to divide by 2. So we're getting x equaling to 1. So that's one answer. We're looking at another one. Over here I'm going to get my x's on the same side, so I'm going to add 4x. We have 6x minus 1 equaling to 3. We're going to add 1. So 6x equaling to 4. We're going to divide by 6. And we have to reduce the fraction. Notice they're both divisible by 2, so that's going to be 2/3. So we're ending up with 1 as well as 2/3. could plug it in. Once again, you could take the answer of 1, plug it in place of all the x's to see if it checks. It should, and it will. 2/3, plug it in place of my x's to check. Might be a good way to make sure that you're understanding the material. Let me give you a second to look at that one, and then we're moving on to problem 9. Problem 9. We're looking for an equation of the line that contains the 2 points, 6, 5, 5, -3. So we're going to have multiple steps on this problem. So let's start off with step 1. I got to find the slope. And since they've given me 2 points, we're going to use m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So I have 2 points. We're going to plug in, so I'm going to call this one point 1, which would be x sub 1, y sub 1. Point 2, which would be x sub 2, y sub 2. So notice the subscripts indicate the point that it goes with. So this is subscript of 1, point 1, subscript of 2, point 2. Alright, let's keep going. We're going to plug in y sub 2, which is a -3, minus 5 over 5 minus 6. So m is going to equal to a -8 over a -1. Have to reduce it down. So m is going to be a positive 8. Alright, now you may be thinking we're finished, but remember they're asking for the equation of the line. So we're not finished. I need to go to step 2. We're going to have to use point slope. Point slope formula is the y minus y sub 1 equaling to m times x minus x sub 1. I would suggest writing the formula because it helps you. And we're going to plug in. We have our slope. Doesn't matter which point to use in reference to the formula. I'm sure you're going to end up picking 6, 5 because the coordinates are positive. It's a little bit easier to work with. So y minus 5 equals 8 times x minus 6. Just plugging into the formula. Got to distribute the 8 because I can't simplify the signs at this point. So y minus 5 equals 8x minus 48. So we're just distributing the 8. We're going to add 5. So y equals 8x minus 43. They didn't ask for it to be in standard form, so that's going to be my answer. Once again, y equaling to 8x minus 43. Let me give you a few minutes on that. Then we're going to be moving to 10. Alright, problem 10. We're saying determine the slope of the line perpendicular to the line that contains the points, a -2, 4, 5, -8. So determine the slope. Alright, so that's a keyword, slope. Also perpendicular is a keyword, so let's circle both of those, just so I don't forget. Alright, so they've given me 2 points, so let's write the formula for finding the slope given 2 points. M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And I'm going to label my points. This is x sub 1, y sub 1, x sub 2, y sub 2. Now, you don't have to do that, but it would help some of you. Help you to not accidentally put the information in the wrong location. Alright, so let's plug in m equals -8. -8 coming from the y sub 2. The formula says I need to subtract. We're going to subtract 4 denominator, x sub 2, which is 5, and we're going to subtract, that's part of the formula, a negative 2. All right, let's keep going. Numerator, I have a negative 12. Denominator, I have a positive 7. Now, you may be thinking we're finished, but remember they're asking me about the perpendicular slope. Alright, so this symbol represents perpendicular. It's like a capital T that kind of flipped over. So perpendicular slope. It's the negative reciprocal. So negative reciprocal of this slope, meaning change the sign, so it's positive, and we're going to flip. So that's 7 over 12. So the perpendicular slope is a positive 7/12. And that's our answer. Notice they didn't ask for any additional information, they only asked for the slope. So the perpendicular slope's a positive 7/12. Now remember, if they asked about parallel, it would be the same slope. So if they had asked me about parallel, this would have been our answer. We would just boxed it in, rolled off to the side, parallel slope. It would be the same, meaning the same as what we have here. Perpendicular, you have to change the sign and flip it. Alright, that's problem 10. Let's move to problem 11. Problem 11. They're asking about x and y intercepts. Alright, so it says find the x-intercepts and y-intercept. Okay, let's just reword that. So let's find the intercepts for a negative 12x plus 6y equaling to a negative 8. Notice we got to show work to get credit. Meaning I can't just write in an answer. I've got to illustrate how I came up with that. So let's go to the x-intercept. We're going to let y equal to 0 because we're trying to find the x. It's lost out in la-la land, and we got to find it. So we're going to plug in 0 in place of y. So I'm just going back to that equation, putting 0 in place of y. This product is 0, which is not going to affect the negative 12x. So just rewrite the negative 12x because adding 0 isn't changing its value. And that's going to equal to a negative 8. Alright, we need to go a step further. We're going to divide by negative 12. We've got to reduce the fraction. So a negative divided by a negative is positive. They're both divisible by 4. So that's going to give us 2/3. So positive because a negative divided by negative. They're both divisible by 4, which is giving me 2/3. We're going to write it as a point. So that's 2/3, 0. So that would be the ordered pair. Alright, y-intercept. One way of finding it would be to let x equal to 0. So we're going to go back to the original problem. Plug in 0 for x. Right, now that product's going to be 0, so that's not going to change the value of 6y. Adding 0 just keeps it as 6y, equaling to a negative 8. Once again, this product's 0, so it's not going to have an impact on the 6y. We're going to divide by 6. A negative divided by a positive is keeping it negative. They're both divisible by 2, so that's 4/3. So we're going to end up with an ordered pair. That ordered pair being 0, comma, a negative 4/3 in your parentheses. So that would be our two ordered pairs, one representing the x-intercept, the other one representing the y. Alright, that's problem 11. Let me give you a few minutes to look at it, and then we're going to move on to 12. specific pieces of information. Alright, so let's rewrite the equation. Alright, so they're wanting us to come up with a graph of the line. So we need to identify the slope and the y-intercept. So let's put it in slope-intercept form. I need to subtract 2x, so y is going to equal to a negative 2x minus 3. My slope's going to end up being a negative 2. So let's go ahead and identify that, negative 2. Y-intercept, negative 3. Some of you need to see that as an ordered pair, so 0, negative 3. And let's identify that, a negative 3. Alright, so let's use that information to graph. Y-intercept, so this is my x-axis, this is my y. It needs to be crossing the y-axis if it's a y-intercept, so that's 0, negative 3. So we found that point. Using my slope, that's a negative 2 over 1. So we're going to think of it as rise over run. So we're going to go down 2 to the right 1. Now you want to keep following that pattern, but it's off the grid. So I've got to find another point another way. So we're going to think of it as a positive 2 divided by negative 1. Meaning we're going to go up 2 to the left 1. Another way to think about it is just going in reverse. Connect the dots, and this would be our line. Should the line be going downward as you look at it left to right? It should. Why? Because the slope's negative. So as you look at it left to right, the slope's going downward, and it should because of a negative slope. Alright, that's problem 12. Let me give you a couple of minutes to look at it, and then we'll move on to 13. Alright, problem 13. Lucky 13. Alright, have absolute value as well as an inequality. Alright, so we've got to isolate the absolute value. That's where we have to start, always and forever. So I need to add 3. I still have absolute value, 3x minus 4, greater than or equal to 12. Alright, so from here I got to determine whether it's an and or an or problem. Notice that the inequality is pointing away from the absolute value, indicating that it's an or. So I have to write the word or. It's a requirement. It's part of the answer. So you're going to drop the absolute value, 3x minus 4. Change the sign of the 12. As you're changing the sign of the 12, you have to change the direction of the inequality. That's part of the process of solving an or statement. Drop the absolute value, change the sign of the number, change the direction of the inequality. Or, drop the absolute value, keep the same inequality, keep the same number. Alright, we're going to solve. We're going to add 4, add 4. 3x is less than or equal to a negative 8. We're going to divide by 3. So x is going to be less than or equal to a negative 8 thirds. 4 is part of the answer, so rewrite it. We're going to add 4. 3x is greater than or equal to 16. Excuse me. We're going to divide by 3. So x is greater than or equal to 16 thirds. Alright, so let's find the information on the number line. On the test, I'll give you a number line. Alright, so here's my lovely little number line. That negative 8 thirds, I need to think of it as a mixed number. So that's a negative 2 and 2 thirds. So a negative 2, think of this as 3 equal parts. We're taking 2 of them. So a negative 8/3. Negative 2 and 2/3. 16/3. That's a positive 5 and 1/3. Once again, think of it as a mixed number. So 5 and 1/3. Alright, so are we including those values? Yes, those values. How do we know we're including them? Because of the or equal parts. We're including them. We're looking for numbers less than or equal to a negative 8/3, meaning we're going to the left. We're looking for numbers greater than or equal to 16/3, meaning we're going to the right. Alright, interval notation. Here's where the fun begins. Keeps getting smaller, parentheses, a negative infinity, comma, a negative 8/3. Okay, what about that negative 8/3? We're including it, meaning I need a bracket. How do we know we're including it? Because of the or equal. We're using symbols instead of the word or, so it's union, a U, bracket. How do we know we're using a bracket? Because the or equal, 16/3, comma, going to infinity, because it's getting larger. With infinity, you always use parentheses. All right, let me give you a second to look at that. If you look at 14, problem 14, and if you look at this step, 14 really follows the same pattern from this step on. So I'm going to leave that one to you. If you're still a little confused with it, touch base with Kirk. You'll have an opportunity in SI to discuss it. But if you reference the steps from here on, it's going to be almost exactly like this problem. Once again, from this step on. Alright, so that's problem 13. We're going to move on to 15. They're asking us to graph. Notice they gave us some lovely little fractions, so let's rewrite the equation. Alright, they're wanting us to graph. They've also asked us to identify the slope of the line, as well as the y-intercept of the line. We're going to multiply through to get rid of the fraction. So what would I multiply through by? Well, someone's going to tell me, hopefully, that we're going to multiply by the LCD, and the LCD being 6. So we're going to multiply both sides by 6. Alright, remember whatever you do to one side, you have to do to the other side. So we have 3x minus 2y equaling to 6. We're trying to solve for y. We're trying to graph. I need to move the 3x to the other side, so I'm going to subtract it. From here, I'm going to divide by negative 2. So y is going to equal to a negative divided by negative, giving me a positive 3/2 x. 6 divided by a negative 2, giving me a negative 3. Alright, so the slope, what is the slope? The slope's going to be 3/2. Y-intercept, a negative 3. That really represents a point at 0, negative 3. Alright, we got to start with the y-intercept. Well, first of all, let's plug in this information that we just acquired. So the slope's 3/2, and the y-intercept's a negative 3. Alright, so 0, negative 3 has to cross my y-axis, which it is. Slope, 3 over 2, so up 3 to the right 2. Up 3 to the right 2. Because remember, you have to have 3 points for my graphs, so don't forget, you need 3 points to get full credit. We're going to connect the dots, and we have our lovely line. Now, should my line be going upward? Yes, it should. So as I look at it left to right, it should be going upward because my slope's positive. Because of my slope being positive. So once again, y-intercept being a -3, we want up 3 to the right 2, up 3 to the right 2. I can even go up another one, up 3 to the right 2, and then connect all of the dots. And that would be our line. Keep in mind there's some other reviews in my math lab. Hopefully you've gone over those. You may have some additional questions you need to ask Kirk. Make sure you're prepared for the test for the next class period, and I hope to see you soon. Take care.